Hey everyone, welcome to our next video. We are starting chapter 5 today. So my first section will be 5.1. I'm going to zoom in a little bit. 5.1, which is systems of linear equations. And specifically, we're going to work with two variables. So first, something we should know is that up to this point, we've dealt with one unknown, so we only needed one equation. If you have two unknowns, then you're going to need two equations. And if you have three unknowns, which we'll do in our next section, you'll need three equations. So one unknown, one equation, two unknowns, two equations, three unknowns, three equations. Also, most of what we'll be dealing with will be in standard form. So I'm going to remind you what standard form looks like. So for a line, that looks like ax plus by equals c. And so since we are dealing with two variables, two equations, we're dealing with lines pretty much. So with lines, with two equations of lines, there are three options that we can have. Our first option we say is consistent, and it's an independent system. And so with an independent system, there will be exactly one solution. And that solution is going to be an xy point. So what will happen here is that we're going to have two lines that intersect each other in some way. Now it doesn't have to be a very good, like it's not perpendicular or anything like that, but they just intersect. And that point of intersection is going to be our solution. What happens here is that our lines will have different slopes. The next type of situation we can see is another type of consistent system, but this one is called a dependent system. And what happens here is that we have infinitely many solutions on the one line. So what ends up happening here is that your two lines are actually the same line. Excuse me. So this one, it's actually just the same line. And so if it's the same line, they'll have the same slope and the same y-intercept. The last type of system we can see is an inconsistent system. And what happens here is that we have no solution. And really what we're going to see with this one is that our lines are parallel to each other. And if you remember, parallel lines never touch, they never intersect. They have the same slope, but they'll have different y-intercepts. So these are our three types of solutions that we can see for a system of equations with two variables. Now there's a few different ways that we can solve systems of equations. The first way that I'm going to show you is to set both of them equal to the same variable. Set the equations equal and we'll solve for our variable. The second type I'll show you is called substitution. And then the last type is called elimination, or sometimes it's called addition. And so there's just different ways to solve these, kind of just depending on what you're given and what looks like it would be the most convenient. So for example 1, we're going to say solve the system. And for the first one, it is x plus 2y equals 6, and then 2x minus y equals negative 8. And so one way we can solve this one is by setting both of these as y equals. Now the reason we may want to do this first is to decide what kind of system we're dealing with. So I'm going to move everything over so that I have the y equals for both of these. So this would be y equals negative 1 over 2x plus 3. For my second one, I would have negative y equals negative 2x minus 8. Keep going, so I get 2x plus 8 here. So I set both of these equal to y. And now I can see that since my slopes are different from each other, so this is going to be an independent system. So that tells me I definitely have an xy solution that I need to find. Since both of these are equal to y, we can set them equal to each other. So I would have negative 1 over 2x plus 3 is equal to 2x plus 8. And then I can solve this for x. Now that I have one equation with one variable. Now, of course, my personal preference, anytime I see denominators, is to just multiply everything by that denominator. That way I can just get it out. So I would first multiply everything in here by 2. That way I could cancel out that denominator. So this would give me negative x plus 6 is equal to 4x plus 16. And that just makes it a little easier to work with. So I'll subtract 16 and I'll add x to both sides. So this is going to leave me with negative 10 equals 5x. Divide by 5. I get negative 2 equals x. Now that I have my x value, I can plug back in to get my y. And we can decide either any of our equations really to plug into. You can plug it into this one, you can plug it into this one, you can plug it into one of these. I would say one of the circled ones because they're already solved for y, so that's just going to be a little easier to simplify. And anytime we can avoid fractions, we probably want to do that. So I'll plug it into y equals 2x plus 8. So I'm going to plug in my x value of -2. So I get -4 plus 8. So y equals 4. So my solution to this problem is the point -2, 4. And again, this is an xy point because this is an independent system. So that point of intersection is the solution to this. So that's why I'm writing it as a point as my answer. All right, let's do another one. This one I have 3x minus y equals 2 and 2y minus 6x equals -4. So first I'm going to make these y equals just so I can decide what kind of system I'm dealing with. So I get -y equals -3x plus 2. And then I get y equals 3x plus 2. For my bottom one, I get 2y equals 6x minus 4. Oh, I missed a negative right here. That should be a -2. And divide by 2, so I get y equals 3x minus 2. Since these are the same line, I have infinitely many solutions. So how I would write this is I would say I have infinitely many solutions really what this is any point on the line y equals 3x minus 2. Now there's different ways to write your answers. I want to see that it's infinitely many solutions and that it's the like the solution itself really is the line y equals 3x minus 2. So that's what we mean by this when we say any point on this line. As long as the point satisfies on that line, it's a good point. It's going to satisfy this equation. Well, system of equations. So that is our first type of solving systems of equations. Sorry, I like yawned and everything all in the same breath and spoke, and it was just a lot. Sorry. Good now. I know in my videos I'm consistently like breathing heavier. It's just, well, you know, as the pregnancy goes on, can't breathe. All right, let's do another one. Example 2, again, I'm just going to say solve, but this one we're going to deal with substitution. And so if you've never done this before, I'll give you the main idea. So what we're going to do here is we're going to solve one equation for x or y, whichever one looks easier to do. And then we're going to plug into the other equation. And so we'll do a few of these. For A, let's start off with 3x minus y equals 6. And then I have 6x plus 5y equals negative 23. So the first thing you want to decide is, do one of these equations look easy to solve for y or x? And I would say this one looks pretty easy to solve for y. So I'm going to do that. So I get negative y equals negative 3x plus 6. And then divide by negative 1. So I get y equals 3x minus 6. Now I'm going to plug this into the y of my other equation. What this will do is it'll leave us with one equation with just x's in it. So I have 6x plus 5. And now instead of writing y, I'm going to write in 3x minus 6. And then it's still equal to negative 23. And now I just have one equation with just x in it, so I'll be able to solve for x. So I get 6x plus 15x minus 30 equals negative 23. Combine like terms. So 21x, if I add 30 here, negative 23 plus 30 is positive 7. And then I can divide by 21. So I get x equals 7 over 21, which simplifies to 1 over 3. Now that I have my x, I can plug in to get my y. Now I already have an equation solved for y, so I'm going to go ahead and plug it in there. So I have y equals 3x minus 6, and I know what x is. It's 1/3. So I get 1 minus 6, so negative 5. So my final answer here is the point 1/3 comma negative 5. So this is just another way to solve a system of equations. I would say the previous method we had, the issue with it is when you solve both equations for y, sometimes you can end up with a bunch of fractions. That would have happened here. So in the 6x plus 5y equals negative 23, if we had solved that one for y and then set them equal to each other, we would just have to deal with a lot of fractions, and it would be fine, but it's maybe not the best way to do the problem. Let's do another one. 3x minus y equals 9, and then 2y minus 6x equals 7. And like I usually say, you should probably try one by yourself. So pause the video, try to solve this one alone. The top equation looks easier to solve for y, so I'm going to do that first. And then I'm plugging that into the y from my other equation. So now I have 2 times 3x minus 9 minus 6x equals 7. Continue solving, I get 6x minus 18 minus 6x equals 7. So this leaves me with negative 18 equals 7. Well, this doesn't make any sense, right? Negative 18 does not equal 7. So this is an inconsistent system, and the answer is no solution. Make sure you tell me that it's no solution. I have one more for us for substitution. This one is a half x minus 2/3 y equals negative 2. And my other one, I have 4y equals 3x plus 12. Now you can decide with this one which one you think will be easier to solve for a certain variable. I'm going to look at the top one actually, because I really don't like to see fractions. So anytime I see a system with fractions, I usually like to just multiply by the greatest common denominator to get rid of that. So with this one, if I multiply by 6, I get 3x minus 4y equals negative 12. And just for fun, let me go ahead and solve this one for x, since the other ones we did y. So I have 3x equals 4y minus 12. Divide by the 3, I get x equals 4 over 3y minus 4. Plug this into my other equation. So now I'm replacing the x. So I have 4y equals 3. And instead of writing x here, I'm writing 4 over 3y minus 4. And then I have my plus 12 still. So all I did was replace that x. Now I'm going to simplify. I get 4y equals 4y minus 12 plus 12. So I get 4y equals 4y, which is 0 equals 0. This has infinitely many solutions. That satisfy the line y. Now this part's a little bit weird. I would just write one of my lines in. So I would just write in like 4y equals 3x plus 12, and that's okay with me. I believe that the homework asks you to solve this for y. So they ask you to write in this. As long as you write the line for me, I don't mind. It's just that line, it can look like so many different things, right? Like we can write it in the y equals mx plus b form. We can write there might be a little break in the video at this point. It's just that I got a call and it messed up my stuff. That's okay. Let me try to repeat what I was saying because I'm not sure what I was saying when I left off. The lines can be written in so many different ways. As long as you are telling me that whatever any points that satisfy that line are your answers, I'm good. Like, I get the point. It doesn't really matter to me the form that your actual line is in, as long as you just write me the line. Alrighty, let's do another one. But now we're going to do another system, like another type of solving. So this is example 3, and we're going to solve these by addition, or sometimes this is called elimination. So the idea here is that we want to add our equations together to cancel out a variable. We may need to multiply equation by something first. And you'll see what I mean by that. But we'll just kind of start off with our first one. So this one is 3x minus y equals 9 and 2x plus y equals 1. So your goal here is to add the equations together, and in that process cancel out one of your variables. So right now, if I were to add these two together, 3x plus 2x would be 5x. Negative y plus y would be 0y. 9 plus 1 would be 10. A 0 in front of this y means that I don't have to write it. So this is just 5x equals 10. And then I can divide by 5. So I get x equals 2. And then just like with all the other ones, you plug back in for your other variable, which in this case would be y. And you can pick whichever one you want to plug into. As long as it has x and y in it, you'll be good. I'm just going to pick this one. No reason. So I'm plugging in my x, so I have 2 times 2 plus y equals 1. 4 plus y equals 1. Subtract 4. 1 minus 4 would give me negative 3. So my final answer here is the point 2, negative 3. So these lines intersect at this point. Alrighty. Another example. So this one says 2x minus 3y equals negative 2. And then 3x minus 2y equals 12. And so my issue here is if I add them together as they are, I'm not going to be able to cancel anything out. So what we can do is we can multiply each of the equations by a number. Sometimes maybe you only need to multiply one of them by something. Sometimes you may need to do both. It just depends on the problem. In this case, we're going to have to do both. So I want to decide if we want to cancel out our x's or our y's. And it really doesn't matter. I'm going to go ahead and cancel out the x's. So what I want to think about is what could I multiply by 2 and what could I multiply by 3 so that they would be the same number, but I do need them to be different signs so that when I add them together, they become 0. And the number that we should try to get to is 6. So I'll multiply the top one by 3, and I'll multiply the bottom one by 2. But be careful. They also need to be alternating signs so that when you add them together, it becomes 0. So I'm going to do -2 for the bottom one. This will give me 2 new equations. 6x minus 9y equals -6. And my second one now becomes -6x plus 4y equals -24. Now, when I add the two equations together, I get 0x, which is what I wanted, minus 5y equals -30. Now the 0x doesn't matter, so we don't really need to write it. This would give me y equals 6 if I divide by -5. Then we plug back in to go get the other variable. And now when you plug back in, you can plug into either of your original equations, or you could plug into the ones that you manipulated. It really doesn't matter. Whichever one seems easier to you. I just go ahead and pick the top one. So I'm going to plug into this equation. So I get 2x minus 3 times 6 equals -2. 2x minus 18 equals -2. Add the 18, which will give me 16. Divide by 2, so x equals 8. So my final answer here is the point 8, 6. I'm just doing some more of these. So I can show you all kind of different ideas. Now, something I told y'all before, if I see fractions, I usually like to go ahead and multiply that by something anyway to cancel any of those fractions out. This one, if I multiply by 6, I would get 3x minus 4y equals -12. Is this the same one I did earlier? Pretty much. It's basically the same as C. It's just like written a little differently. But that's okay. It's just more ways to look at them. So I have 3x plus 4y equals 12 for the second one. So if I add these together, I get 0x plus 0y equals 0. Okay, this means that I have infinitely many solutions. So this is infinitely many solutions on the line And like I said before, I just usually write the line however it's being written to us. But I can't fully remember how the homework has you type it in. They may need you to like solve it for y first. But it should tell you. And for part D, we'll just see one more. 0.2x minus 0.4y equals 0.5. I want to show you what you can do if you end up with some decimals. I've done this before in this class, but you can always just multiply by something. So if I multiply this by 10, it would become 2x minus 4y equals 5. That's way easier to look at. If you want to multiply the second one by 10 as well to get rid of the 1.3, you can do that too. Completely up to you what you like. Let's do it. Why not? I'm doing these by hand, so might as well get rid of any decimals. So this would give me 10x minus 20y equals 13. Now we can decide, do you want to cancel out your x's or do you want to cancel out your y's? If I want to cancel out, let's say I want to cancel out my y's for this one. Well, I can multiply negative 4 by negative 5, and that would get me to positive 20, so that when I add them together, they would cancel. So let's do that. So give me negative 10x plus 20y equals negative 25. At the bottom, I still have the same equation. When I add these together, though, I get 0x plus 0y equals negative 12. Well, 0 does not equal negative 12. So this is no solution. Make sure you tell me that is no solution. And so these lines are parallel. Now for our last example here, we do have to do a little bit of modeling. So we're going to do some word problems. The only thing about the word problems is that we have to make our own equations. So modeling, which really is just word problems. Now we've actually done this a little bit, like making our own equations. When we did, it was the section that we did perpendicular, parallel, and then I had like the cost equation or something. So we're going to do a little bit of modeling here. So example 4 says, and I mean, this is just taken from one of our books. It says, at Starbucks, an orange smoothie, and I mean, this is just made up, contains 16 grams of protein and 5 grams of fiber. A chocolate smoothie contains 21 grams of protein and 6 grams of fiber. How many smoothies of each type would you need to consume 243 grams of protein, which is kind of insane, and 72 grams of fiber? And you can just pause the video to go ahead and write this down. We need to first decide what is our x and what is our y. Usually, whatever it's like asking about is usually your x and y. So since it says how many smoothies of each type, that's going to be my x and y, is the types of smoothies. So my x, I'll say, is number of orange. And then I'll let my y be the number of chocolate. And so then we can make equations with our other information. So I know that my orange smoothie has 16 grams of protein, 5 grams of fiber. The chocolate has 21 grams of protein, 6 grams of fiber. Now I need both of my equations to have x and y in it. So what I'm going to compare is the fact that orange has 16 grams of protein and chocolate has 21 grams of protein. So basically I'm going to make a protein equation. I've written protein too many times. It doesn't look like a real word to me anymore. Isn't that always weird? I feel like I'm spelling it wrong, but I'm not. Just doesn't look good. Sorry, I'm getting distracted. All right, so my protein equation, so I have 16 grams for the orange, so that's 16 times x. And then I have 21 grams of protein for the y, so that's 21 times y for the chocolate. And I need 243. For my other equation, I'll do one for the fiber. So for my fiber, the orange has 5, chocolate has 6, so that's 5x plus 6y, and I need 72. Now for this one, you can decide how you would like to solve it. If you think maybe substitution would be easier for you, if you think setting them both equal to y would be easier for you, if you think elimination would be easier for you, You can pick whatever way that you think. I will say that the numbers being kind of large on this, none of them really are great, right? Because if I do elimination, I have to multiply both equations by something. If I do substitution, I have to deal with fractions, which is always frustrating. So you just kind of got to pick whatever one you want. What I would do is first I would try to give you smaller numbers so that you don't have to worry about it as much. But I would just multiply one of them. I'll try to cancel out my x's. So I'll do this one times -5, and I'll do this one times positive 16. I'm making one of them negative so that they cancel. So let's see what I get. 5 times 16 is 80. So I get negative 80x minus 21 times 5 would be 105. 243 times 5 is 1215. For my second equation, I'll get 80x. 16 times 6 is 96. And 72 times 16 will give me 1152. Now I can add these two equations together. So 105 negative plus 96, that'll give me negative 9y. Oh, I missed a negative right here when I wrote this. Be careful. I get negative 63. So if I divide by 9, I'll get y equals 7. Then I can go plug that into my other equations. So I get 5x plus 6 times 7 equals 72. 5x plus 42 equals 72. So give me 5x equals 30. So x equals 6. So my answer here is I need 6 orange and I need 7 chocolate. I don't know who is drinking that many smoothies in one day, but go for it. Now I have one more for us of another word problem one. This one deals a little bit with money. So it says 2 DVDs and 3 CDs cost $78. 1 DVD and 4 CDs cost $74. What is the cost of a DVD? So again, usually what it's asking you for is what you want to make your variable. So in this case, it's asking the cost of a DVD. So I'm going to let X be my cost of DVD. I'll let Y be my cost of a CD. And then it kind of sets up the equations for us. 2 DVDs, 3 CDs, $78. So this equation would be 2x plus 3y equals 78. My other equation would be 1x plus 4y equals 74. Since for this one I don't have a variable in front of x, let's go ahead and do substitution for this one. So I'm going to change this to x equals negative 4y plus 74. And I'll plug that into my other equation. So I get 2 times negative 4y plus 74 plus 3y is equal to 78. Simplifying, so I get negative 8y, and that would be 148 plus 3y equals 78. So I'll get negative 5y equals, let's move that 148 over. So this will give me negative 70. And divide by negative 5. So negative 70 divided by negative 5 will give me 14. Now that gave me my y, but that's not what I wanted, right? I wanted the cost of a DVD. So I got to go plug that back in. So negative 4 times 14 plus 74. So let's see, that'd be 48 plus 8. That's going to give me negative 56 plus 74. So I get x equals 18. So $18 for a DVD. Kind of crazy. And so usually when it comes to the word problems, I'm not picky at all about how you solve them. On the test, I do usually tell you how to solve the systems. Like I'll say solve by substitution, solve by elimination, something like that. Usually that's not me being picky just to be picky. There's actually a reasoning for it, and I'm probably picking the best option for you. So I'm not saying like you have to, you know, like the reason I show it a certain way is so that you can do the best way. Hopefully that makes sense. All right. Well, as always, I hope you'll have a wonderful day/night. I'm recording this at night. So, and if you need any help, if you have any questions, always reach out to me. Let me know. Bye bye. I'll see y'all in the next one.